This is now experiment 27 in the lab manual, where we have our optic bench, we have a light source, right? So basically this arrow with the light behind it, that's going to represent our light source or our object. We have a lens, so we have a lens holder. Right now I have a 10 centimeter focal length converging lens. So you guys may know by now, hopefully you do, that the double convex lenses are the converging lenses. So the rays come together right when they pass through. And then over here, the screen is going to be where the image is. Okay? So in this case, I have the object distance set up. I have the lens itself, the lens holder is at 50 centimeters. The object is at 30 centimeters. So that means that the object distance is going to be 20 centimeters. And then what you have to do is what you're supposed to do, and I'll help you guys here, is figure out what the image distance is. What is the distance from the lens to the screen when the image is in focus? Okay. So in this case, I'm going to move this around until it becomes focused. Then I'll zoom in to kind of show you where it's actually focused. So it looks like it's probably around maybe right around there. Okay, so I'm getting around 69.7 centimeters. So let me zoom in to show you this. And you'll see on the screen that that image is focused right on the screen. Okay, I'll zoom back out again. Okay, so to calculate the image distance, you're just going to find the difference between those two values. So it'll be 69.7 minus 50, right? And that will be your image distance. And then you can use the thin lens formula to calculate the focal length of that particular lens, right? In this case, the 10 centimeter convex lens. All right, let me do the same thing now for the 12.5 centimeter double convex lens. So I'm putting the 12.5 centimeter lens in the lens holder. I'm going to keep the object distance the same, so that will remain to be 20 centimeters. And then I'm going to move that screen to figure out where this is focused. And in this case, probably somewhere right around there. I'm going to say 81.3 centimeters. So 81.3. Okay, so now if we want to know the image distance, it'd be 81.3 minus 50, and that will give you your image distance, which we're calling DI. Here, let me zoom in to show you that this is fairly focused at that location. So you can see the image on the screen. It's fairly crisp. All right, let me go back out again. There's one other thing that we need to do here. We need to measure the object size and the image size so that we can calculate the magnification. Okay, so for the object size, I'm just going to measure the length of the arrow from the light source in centimeters, and it turns out it's around 3.4 centimeters. Okay, so the object size is 3.4 centimeters, and that's going to be the case for both the 10 centimeter lens and the 12.5 centimeter lens. So you can fill that in your table. And then for the image size, I'm going to measure the length of the arrow on the screen. In this case, it looks like it's around 5.4 centimeters. So around 5.4 centimeters And that one was actually the 12.5 centimeter. Let me go back to the 10. Forgot to do this with the 10, so I'll put it back in the 10. I'll move the screen back to, where was it at, 69.7, so that it's focused. So 69.7. And then again, the object size is the same as before, right? Because that hasn't changed, so that's going to be 3.4 centimeters. And now for the image size, this is for the 10 centimeter focal length. I'm getting around 3.3 centimeters. So around 3.3 centimeters. Okay, and then the final thing that we need to do in terms of data collection is we need to calculate the image distance when we have a combination of the 10 centimeter converging lens and the 20 centimeter diverging lens. Okay, we have to put them together actually. So I'm going to put these in the lens holder together. So something like that. I want to set the object distance to be 40. So remember the lens is already at 50 centimeters. So I'm just going to move this to 10. So now the object is at 10, the lens is at 50, so that object distance, DO, is 40 centimeters. And then finally, I'm going to move the screen until it's focused. And that will give me the image distance. Probably somewhere I'd say like right around there. So I'm getting around, looks like 88 centimeters. Okay, so if you do 88 minus 50, that will give you the image distance for the combination of those two lenses. Remember, there's a 10 centimeter converging lens and a 20 centimeter diverging lens together. Okay, and that should be all the data that you need to calculate the focal length of that double concave lens or the diverging lens. And again, I'll explain all of that in another video. This is just for the data collection.